In this session, we're going to look at lessons 60 and 61. In lesson 60, we're going to look at two different types of trig functions, just adding more to this concept. This is a lot of what this class is about. What you're going to do is you're going to notice this is a difference of two squares. And so you're going to separate this to tan theta minus 1 and tan theta plus 1 equals 0. You're going to set both of them equal to 0 in order to solve for them. And so you're going to get tan theta minus 1 equals 0, tan theta plus 1 equals 0. So tan theta equals 1, and then tan theta equals negative 1. So the question is, when is tan 1 and when is tan negative 1? Well, when you put it in your calculator, because they gave you a side, and you're going to be finding an angle, we know to use second function or tan to the negative 1, and we will put 1 in. When we do that, we get 45. And what you'll notice is we're in the 45-degree family. Go ahead and do the other one. And so you go second function, tan to the negative 1, negative 1 in there. And when you do that, you get negative 45 or 315. Remember, there's always 2. And so since we're in the 45 family, you know it's 45, 135, 225, and 315. Now, we've already discovered it's these two. If there's always 2, it's just going to be all 4 of them. You can put it in your calculator to double check it, but these actually are going to be your answers because it is all 4 of the options for 45. In this next example, we have sine squared theta minus sine theta equals 0. What we're going to do is we're going to factor out a sine theta, and what you're left with is sine theta minus 1 equals 0. So the two options is sine theta on the outside equals 0. And the one on the inside is sine theta minus 1 equals 0, which isolates to sine theta equals 1. So the question is, when does sine theta equal 0 and when does sine theta equal 1? Same thing, because you have a side, you're going to put sine negative 1 equals 0. Well, the answer to this one is going to be 0, not theta, 0 degrees. And then on this other one, when does sine theta equal negative 1? Well, you're going to get negative 90, which is the same as 270 degrees. Whoops, I messed up. I put in negative 1. It should have been sine theta 1, because that is what it was. It's actually not negative 90. It is 90 degrees. And then you will also find when you put in sine 180, you get 0. So there's actually 2 zeros. You remember this is in the 0, 90, 180, 270 family. And we found that these two are 0 and this one was 1. So it's going to be all 3 of those answers. This last one is similar. What you're going to do is you're going to bring sine x back to this side, and you get negative sine x equals 0. Then we're going to factor out the sine x. So when you do that, sine x on the outside, 2 cosine x minus 1 is left on the inside. So we're solving once again for 2 things. Sine x equals 0, already done. 2 cosine x minus 1 equals 0, which you bring the 1 over and then divide by 2. So it becomes cosine x equals positive 1/2. So the question is, when is it this? Of course, if you have a side, second function sine of 0 equals, that is going to be 0. And then when is cosine x, second function cosine x, 0.5. It's in the 60-degree family. Remember, there's always 2. So you can go cosine, we can go 120, that's negative. Cosine 240, that one also is negative. So cosine 300, that is positive. So 0, 60, and 300 are our three answers for this last one. There actually is one more, that sine is 0 at 180. So this one had 2, and this one had 2 also. So 0, 60, 180, 300. The next concept that we're going to be looking at is found in lesson 61. And in lesson 61, it started out, we talk about a bell curve here. And that's what this is, the bell curve. And all it is, it's the idea of how numbers are grouped together in average and different things. And, let's say that students were taking a test and, they got a certain amount of grades. Well, what they say in this bell curve is that 68% of the students are going to be one standard deviation away from each other. 95% will be 2 standard deviations away from each other. And 99% will be 3 standard deviations away from each other. And the way to look at this is you might get an example and they'd say the mean of distribution that is approximately normal is 100 with a standard deviation of 5. And so, let's say that, and obviously this wouldn't be a good one for the example of grades, but let's say grades was 100 and the standard deviation was 5. Well, the way that this works is you have 68% of them will be one standard deviation either way of this 100. So if 100 is the number, 5 away this way, you'd be plus 5 would be 105. And 5 away this way would be minus 5, so it would be 95. So you would say 68% were from 95 to 105. That was their range. 95% is going to be 2 away. So instead of 5 this way and 5 that way, 2 away would be 10. So it'd be 10 this way and 10 this way. So it'd be 90 to 110, or 5 more this way and 5 more this way is the way you look at it. Then the last one is 99% is 3 standard deviations away, or instead of 5, that's 1 standard deviation, or 10 is 2 standard deviations. 15 is 3 standard deviations away. So 99% of them were 3 standard deviations away from the norm. So it'd be another 5 this way, so it'd be 85 to 115. And this right here would be your answer on how to do these bell curve type problems. And by the way, this is a standard, so it'll always be these numbers right here. You put those on your formula page and use those every time to solve for these. Not difficult on the math side at all, if you just understand the concept and remember those norms. The next concept, or the last concept of lesson 61, has to do with average and standard deviation box whisker problems. What you're going to have to do on your calculator is you're going to have to go and press the stat button. And when you do that, you're going to edit and you're going to put stuff in your window here. You can see on this problem up above the calculator, you have 15, 7, 12, and 10. So I have put those numbers 12, 7, 15, and 10 in the calculator. When you do that, you're going to go to Stat, Calc, and then you're going to hit that variance there. Make sure list 1, which is the one you entered, is the one that's there. Hit Enter to calculate, and it's going to give you several numbers. If you look here on the list that I provided on the board, variance is something you'll have to figure. Range is from the biggest number to the smallest number. So the range from this one would be 12 to 7, it would be 5. Standard deviation, it's given to you in the calculator. It's that funny symbol right there. It's kind of a O with a line with an X. So standard deviation is 2.92 in this problem. That's given to you in the calculator. And then I think the other thing they wanted in this particular problem was they wanted the mean. And the mean in this, in the calculator is at the top. It's 11. It is the X with the line above it. So that's how you're going to solve for things with this type. We'll do another example. We'll do a box whisker problem. All right, so the last example we're going to look at, they gave us a bunch of different numbers to put in. They gave us, I'll just show you here because I put them in the calculator. They gave us 16, 22, 28, 33, 35, 40, 50, and 120. And I entered all of those into the calculator. And then I went to Stat, Calc, and then go ahead and calculate that. And it'll give you the numbers that you need. Now in this problem, they asked for different things. They wanted the mean, the standard deviation, the min x, the median, the Q1, the Q3, the max x. And all of those numbers you will be able to come up with by using your calculator. Another thing that they want you to do is they want you to create a box whisker problem or a graph, all right? And this one will label everything. You have the min x, you have the max x, you have the Q1, that's right there, the Q2, this is the median right here, and we could come up with all of these different problems, or all these different answers by putting in what we got from our calculator. Now our mean was our x, remember it's the x like this, and that is 43 in the calculator. Then our standard deviation was given to us. It is, remember that is this symbol, kind of like that. And it is 30.71. And then our min x is 16 here. Our Q1 is 25. Our median is 34. And these are literally given to you in the calculator. Our max x is 120. So these are all the problems that we should need here. So our min x is 16, Q1 is 25, median is 34, our Q3, not Q2, Q3 is 45, and then our max x is 120. Now we're going to do a little experiment here. What we're going to do is we're going to take our range from 45 to 25, which is 20, and we're going to multiply it times 1.5. When we do that, we're going to learn the range of what we need here. This is going to end up being, let's see, 20 times 1.5 is 30. So 30, and this is just a number, 1.5 you'll have to remember every time. But 30, so you go from the Q3 and add 30. So 75 is actually our, 120 was our max x in the calculator, but it's too far away from our numbers. So 30, which is 1.5, times the range of these guys, and 1.5 is a standard, and so 30 is going to be our number that it can't be farther than either way. Now, 30 minus 25 is -5, so 16 is plenty in that range as our min x. We can keep that. If 120 had been under 75, we would have kept it as our max x. But anytime you're maximum, you still label the 120, but 75 is our max x. So this is how you label. This is called a box whisker problem right here. This is what it would look like to label and write down your answers for a box whisker problem. So that's how you solve for those. You have to watch that over and over, maybe, to go through some of that.